Hello and good day to you. So my previous, I feel like I wrapped up on clustering. There's one more thing I could do about it, which would be just a last sort of caveat of using k nearest neighbors and using clustering algorithm to make a classifier. And I eventually decided against it because what I was going to use that video for was to introduce the idea of that the end goal in most of these data science processes is to build a model, and usually that model is some sort of machine learning thing, machine learning beast. But it could be anything. And in this case, I decided not to because I think that you can figure out a k nearest neighbor if you go and look it up and you've looked at the k means clustering, but also because I wanted to sort of move on to linear regression because there's this beautiful thing with linear regression in that you will have done it at school and you won't have realized you've done it at school, and you won't have realized actually how potentially useful it might be outside of school because it's very badly taught to my mind. Now, very, very quick algebra rehash. Y equals, if you remember, you have x and y, and y as your output equals x times m, and m is the value that you multiply one value by another, and u plus b. So what you're saying is my output value variable, and in this case we're using this graph, which I will explain why it's not a nice straight line in a bit, but don't worry about that. Imagine that there was a nice straight line going across this data, and you've got your prediction that you want to say how much is my house price worth, and you then got the house age and using that as a prediction. Well, if you had your nice little line, you'd go across, you'd go up, and you'd say for a house of age 20, look across and you'd say this is how much I expect it to be worth. Now, there's lots of complexity involved in that. In the real world, house price is going to have a level of randomity that values are going to appear above and below that house price, but you can use a line drawn on a graph as a predictor, and you do it by finding out how much an increase in x affects the y, which is your m, and how high or low it was on the y graph when you cross the zero axis for x. Now, you can see here this data looks terrible if we were to just draw a straight line across it. But what I'm going to introduce you now is the idea of a general linear model, and the idea is to mix in multiple different variables to create a line that is a mix of these different variables and does better than this, and then show you a quick way of how you would assess it. So you create a linear regression with LM, you tell it where the data is you want to predict, and then R lets you do something very great. You can put in, and I've only put 2 in because it makes my life easier for explaining it afterwards, but you could put in multiple variables of numbers, and have to be numbers. There's a way of dealing with categorical data, but I'll explain that in a future video. But you've then got here a value of results which predicts house price and uses transaction date and the house age as 2 values that it's trying to use. Now, if you were to use print on this results object, which is your linear regression, you can see that the intercept is your B, and then you've got an M for house age and transaction date. So you can see you could very quickly produce a little algebraic calculation, drop it into an email and send it off to somebody to say this is what we think is a rough guess for this. And part of the data science is then to look into it and make sure that it's as accurate as can be, and future lessons will be going on about confidence intervals and the like. But the idea just to introduce you to this concept of you can make this general linear model, and it's very quick and it's very simple. So you can then go to your summary, and your summary gives your min, max, and median. So you know rough, and that's for the residuals. Now your residuals, to introduce the concept, is the actual minus the predicted. So it's basically how out it was. So if the residuals are really high, you know you're kind of out there. And you can see here the maximum amount was 76.95 and the median is 1.645. 1.645 is not bad in my mind, but you've got your first step in sort of making an assessment of, you've just developed this model. You might try putting in different variables, adding a few more variables, because I've only taken 2, but you could keep on adding more. And then you can also do plots of the residual to show people. And I have to do a whole video on residuals because it's a little bit like looking at tea leaves sometimes, because the stuff you can get about the underlying data, which I feel is very easy to spot looking at residuals. But I will show you, there's your line for what the linear regression is trying to predict, and those are the different variables, and you can see that they're roughly plotted around that line. And you can see for basically two x values I picked at random. It's not a bad model. I could probably improve that a lot. You've then got the quantiles, and this I'm going to have to go into this in more detail. You can see sort of a little bit of the wiggle of the data, and then you get on to residuals and leverage. Now we'll have to spend some time writing up some videos to explain those residual views. But you can see from the first one that it's a 90% of what you need to go and explain to somebody why they should trust the given linear regression. And in a world where we're talking about AI and neural networks a lot, but we also have to look after a customer and people who frankly will not understand AI, and AI is just really hard to explain. Like it's a major issue, actually, scientifically speaking, working out the exact reasons why a given neural network came up with a value. But it's not that problematic with linear regressions, and I think I've just shown you that it's not that problematic. So as a sort of tantalizing suggestion of why you should continue watching and subscribe and like and that stuff, it's because this is maybe a slight alternative that you could use in place of a neural network. So I hope that's been interesting for you. Thank you. Good day, good morning, good night. Bye.